Alright, in this video we're going to solve a few logarithmic equations with variables in different places, okay, in the problem. Alright, so number 18, we have to solve this. In most cases we're going to wind up writing the problem in the other form. So I'm talking about we have log form, so I'm usually going to wind up rewriting this problem in exponent form. Okay, and so remember, for example, if I have log base b of p equals q, this is log form. If I wanted to write exponent form, I start with the base, which is b. All right, there's my equal sign. Now these other two things will wind up switching sides. So this p is going to come over here. This q is going to come to the left, but it will be the exponent in exponent form. So that's what I'm going to do here. In exponent form, this would be a. So I start with the base. I'm going to bring the -4 over. All right, so I've got this -4 power, and that's going to equal 625. All right, these two basically switched sides, and this became the power. Now there's more than one way to solve this, but my favorite way to get this base by itself is to raise both sides of the equation to the reciprocal power. So the reciprocal of 4 is -1/4. So I'm going to do the -1/4 power on both sides of the equation. So over here, -1/4 times -4 is 1. So basically those cancel out. So that's just going to leave me with a by itself, which is what I want. So now I just have to simplify this somehow. This is not going to be a negative answer. When you have a negative exponent, what it does is it drops the expression down to the denominator. So I will have 625 to the 1/4 power. Okay, now you don't have to show this next step. Just in your mind, understand that the 1/4 power is the same thing as the 4th root of 625. But you can feel free to go straight to the answer. All right, we're going to use an exponent table to find the 4th root of 625. Okay, so the 4th root of 625 is 5. Okay, so this would be 5. So the answer is 1/5 for number 18. All right, let's look at number 19. Again, I'm going to write this in the other form, exponent form. Now this is the base. All right, it's pretty weird looking, but it's the base. So always start with the base. So I'm going to drop that down. 1 over 256. Now these two things are going to switch sides. All right, so this -3/4 is going to come over to the left side, and in exponent form, that is the exponent. And the x is going to come over here. So that's, again, very useful because this x is now by itself. So I just need to simplify this. Now, when you have a negative exponent on a fraction, just a quick example, if I have a over b to the -2 power for a simple example, you do the reciprocal. So this would be the same thing as b over a to the +2 power. All right, that's worth memorizing. So you do the reciprocal, and then it'll be a positive power. So that's what I'm about to do right now. So I have this fraction, negative exponent. I'm going to do the reciprocal. Now the reciprocal of 1 over 252 is just 252. Whoa, that's supposed to be a 6. All right, so the reciprocal is just 256. And then this will now be a positive 3/4 power. So it's just a matter of evaluating this. Well, when you have a fractional power, what you really are looking at is power over root. Power over root. So the 4 is the root. So that means that what we're really looking at is the 4th root of 256. And then 3 is the power. So that would be the 3rd power. So the 4th root of 256, I'm going to use the chart to help me out. The 4th root of 256 is 4. All right, so that means I have 4 to the 3rd power. And 4 to the 3rd power is 64. All right, you could even use your chart for that if you needed to. 4 to the 3rd power is 64. So that's the answer to number 19. All right, finally, number 20. Now, again, I'm going to rewrite this in the other form. So this would be, let's see, 1,296. All right, that's the base. I bring that down. The n is going to come over here as the exponent, and the 6 is going to come over here as the base. Not the base, the 6 is just going to go over there. So I'm asking myself, what power turns 1,296 into 6? Now you see that it's getting smaller. That means what we're really dealing with must be some kind of a root. 1,296. It must be some root. So what root is turning, I shouldn't just put an n there. I'm just going to say question mark. What root is going to turn 1,296 into a 6? Let's use the table. Let's see. So we're trying to turn it into a 6. Here's 1,296. So the 4th root of 1,296 is 6. Okay, so the 4th root would do it. So this is a true statement. But the 4th root, because we really want this in terms of a power, all right, so just understand that the 4th root is the same thing as the 1/4 power. So what power will turn 1,296 into 6? That would be the 1/4 power. So that's why the answer here is 1/4. All right, so that is the answer to number 20, is 1/4. Just for fun, I'm going to show you one more way to do it. We could evaluate this using the change of base formula. The change of base formula says when you have a logarithm, you can split it up as a fraction, and you'll do the log of 6 over the log of 1,296. Now you can make the base be whatever you want, but you might as well choose the base that they both have in common. So can we find 6 and 1,296 in the same row on this chart? Well, there's 1,296, and there's 6 itself as the base. So both of these can be written as base 6. So that's the base we would use. So we could look at this as log base 6 of 6 and log base 6 of 1,296. So we could do it this way. Now, looking at the denominator first, because that's more typical, what power turns 6 into 1,296? Well, that was the 4th power. Whoa, wrong button. That was the 4th power, so that means this is 4. Now, what power turns 6 into itself? Well, 6 to the 1 power is 6. So that's another way of getting that the answer number 20 is 1/4. Same as we got before. All right, that'll do it. I hope these videos have been helpful.